Hey everybody, welcome back to Math We've Got This. This is Mr. Stewart here, and this is part 2 of 2 on the topic of the distributive property. So in this particular example here, we have a monomial, that's this term here up front, so this multiplier, and here we have a 3-termed expression or algebraic expression known as a trinomial. So now we could use a rectangular array to help us with this, and I would encourage you to do so if that's something you want to do to help visualize the multiplication. But I think in this video, what we'll do is I won't use the arrays per se, but you could look back to part 1 to see how they were used. So let's do our distribution. So we're going to take that multiplier, so the p, and we are going to multiply it over every single term. So p multiplied by p squared, then p multiplied by negative 2p. Okay, so take the sign with it. And then thirdly and lastly, p multiplied by the positive 1. And also remember that the exponent on p here, this multiplier is 1. Also here in the 2p term, it's a 1. So what I'm going to do, I don't normally do this, but I'll do this for the first couple of examples, is I'm going to write down the partial products without actually having multiplied them. So it would be p, that's p to the 1, multiplied by p squared. And then we're going to be adding on p to the 1 multiplied by negative 2p. Of course, that's p to the 1 as well. And then we'll add on p, or p to the 1 multiplied by 1. So this partial product here ends up being p cubed using the multiplication rule for exponents that have the same bases. This term here, instead of adding a negative, we're just going to subtract. So we'll subtract 2 and then p to the 1. Let me just use a different color to highlight this. So p to the 1 multiplied by p to the 1 over here is going to give us p squared. So that would be minus 2p to the power of 2, and then p times 1 is just the variable p. And there you have it. This example, now going back to my word here, I mentioned I wouldn't be using an array, but I want to show you a slightly different type of array here where we're going to end up having 4 partial products. So let's take a numerical example just to start things off, and we're going to multiply 18 by 25 using the array. So let's put our 18 across the the top or the bottom. So we'll make this a 10. You can make it really whatever you want. You can split that into any 2 atoms you like, as long as you get 18. And I think conveniently we'll use 20 and 5. So here you've got 5 by 10, 5 times 8, and up here you've got 20 times 10, and then 20 multiplied by 8. So 18 multiplied by 25 then becomes the following. So we can use partial products. So I could, as I've done already, I could break the 18 into 10 and 8. And over here, I can break that into 20 and 5. So what's really interesting is that the array over here to the left really tells us how to multiply 2 groups together when they both have 2 terms. So we have 2 pairs, or a pair of binomials. So that means the partial products are as follows. So we have 20 multiplied by 10. So I'm just going to flip that around because I ended up writing my terms in a slightly different order. So 10 multiplied by 20. So that's our first partial product. Now the next partial product, I'll go 10 by 5. And I'll explain that in just a moment why I'm kind of choosing that order. So I'll add that partial product on. I'm running out of space. I'm just going to drop down, use a square brace to show that. So next partial product will be 8 multiplied by 20. And the last partial product will be 8 multiplied by 5. So altogether, 200 plus 50 plus 160. I believe that's 90 on the end. 5/8. It looks like an 18. That's supposed to be a bracket. Let me just highlight that. That's a bracket. So, and now it looks like 18 times 5 still. So let's change that out. Let's just erase that and we'll do a better job at writing that in. So that is 8. It is 8 times 5, giving us 40. So then altogether, that looks to be a total of, let's see, that's 200 on the end. Another 200 is 400, so 450. Now, the neat thing about having the array here with us is that it really helps us to organize the partial products. So what it does is it reveals that this binomial, you take the 10 and you have to multiply it by each term in the second binomial. It looks kind of characteristic of the stuff we did in the first video. And then we have to take the other term in the binomial, and that's the plus 8, and we have to multiply that over each term in that other binomial. So we're applying the distributive property twice in order to multiply binomials. So that might be something worth writing down. In order to multiply binomials, you're applying the distributive property twice. So this video will be a little bit longer than the first one because it focuses on multiplying binomials. So let's take care of that. So we can do this one with an array. It's actually prompting us to do that. So let's draw something here, something that would represent that. Okay, I'm sure that's fine. So let's kind of divide this up a little bit. Again, it doesn't really matter. It's just an organizer. So I'm not worried about proportion or how large particular terms are. We'll just do that, and we'll add the dimensions on. So our binomial is x plus 3. That's the first group, first term. And then the other one being 2x minus 2. So we'll put the 2x here, and we'll put the negative term here to represent that length. Now the distributive property would tell us that we have here, we'll take the 2x and multiply it by the x. That fills that box out. Down here, we would have negative 2 multiplied by x. And that fills that out. Might as well keep going here in the bottom. So negative 2 multiplied by 3. And here would be 2x multiplied by 3. Okay, so at the end of the day, you can really see how the array, once again, is really useful in organizing the multiplication. That is the formation of all the partial products. So what I'm going to do is I'm going to go back to the expression here, and I'll just sort of model what we were doing with the array. So if you look at your top left, so I'm just going to kind of focus on this one here, put a little check mark on that. What we're doing is we're multiplying the x and the 2x. And then also, if we take note, let's focus on the bottom left, the negative 2 and the x. That would be these two terms being multiplied together. Changing colors up here. So this one here, we'll just put a double check on that so you can see what I'm doing. So that's 2x multiplied by 3. And then your last term, the negative 6 as a product, would be 3 multiplied by negative 2. So in our last line, or really the only line in our solution, so x multiplied by 2x, that gives you 2x squared. And then x multiplied by negative 2 is negative 2x, so we add negative 2x. So I'm just going to show that as subtracting 2x. And then 3 plus 2x, 3 multiplied by 2x, so that's plus 6x. And then 3 multiplied by negative 2, which we have here, right, that last partial product, is plus negative 6, or just minus 6. And we're pretty much there. The only thing I want you to notice, and this is a little different here, you may not have seen this before, but notice that this term is an x term. This ultimately becomes an x term, whereas this is an x squared term, okay? And this is just a constant down here, negative 6. So what's really interesting is that this pair of terms here, these end up being like terms. And you know that when terms are like, we can combine them through addition. So what we'll do is we're going to take these two terms. We're going to simplify by bringing those together through addition. So our last step then is to write that as 2x squared, and negative 2, right? The negative 2 plus the 6, that gives you positive 4. So it'd be plus 4x, and then minus 6. All right, final two. Here we go. So these ones are a little lengthier. They have multiple expressions in them, but the same thing applies. Look for how you can use the distributive property to get the job done. You could use multiple arrays for this, but at this point, why don't we just focus on using the distributive property with these expressions? So let's take the negative 4, we'll multiply that over the x, and we'll multiply that over the positive 3, and then the 2 will be multiplied over the 2x as well as the negative 1. So let's calculate those partial products. So negative 4x and negative 4 multiplied by 3, negative 12. We're going to add on to that. 2 multiplied by 2x is 4x. And then 2 multiplied by negative 1 is negative 2. So we're adding on negative 2. Now you'll also notice that there are like terms here as well. So we have our x terms. So we have our negative 4x, our positive 4x, and then we have our constants, which are terms that contain no variables. Well, they do, but the power, the exponent on the variable would be 0. So that's a story for another time. So let's group these terms together. Let's kind of reorganize this. So we'll put the negative 4x plus the 4x together. Oh, that's convenient. That's a 0 term. It's a 0 pair. So yeah, these are gone, right? That's a 0 pair. Sorry, tablet's kind of running away on me here. Let's revise that. That's not appropriate. So let's get rid of that. Let's rewrite this. We can make that look a little bit better. Okay, so that is a 0 pair. And then we have our constants. So we have a plus negative 12, and then plus another negative 2. So in total, minus 14. Interesting, eh? To know that we have an algebraic expression, variables are involved, and works out to be a constant in the end. Okay, last one. All right, so this one here, I've chosen this one because it has multiple sets of parentheses. So it's got inside here, we've got a 2k minus 1 as a group. So we're using round brackets there, and then we have these braces or square brackets to kind of envelop or surround a larger expression. So again, we are using the distributive property, but I do want you to recall that the order of operations, whether you use BEDMAS or PEDMAS, applies. So what we want to do is we're going to work inside the square bracket. Now also recognize in the square bracket we do have 2k minus 1 in brackets. So what we need to do first is we have to remove its brackets by distributing the 5 over top of the 2k and the minus 1. So let's do that first, and then we'll keep going. So I'm going to rewrite the 3. It's going to keep that large square brace there. And then 5 multiplied by 2k, that's plus 10k, as 5 2s are 10. And then 5 multiplied by negative 1 is negative 5. So I could show that as plus negative 5 or just minus 5. Now, if you look at what we have inside the brackets, we have our like terms. In fact, just the constants. So we have 2 and negative 5. So we could rearrange those, or we can just go for it. And what we'll end up having, I'm just going to switch to some round brackets now. I don't see the need to keep the square braces. So 2 minus 5, that's negative 3, plus the 10k. And then we'll use the distributive property one more time. So we'll multiply 3 over negative 3, 3 over positive 10k. And last but not least, here we go, final line. So that's negative 9 plus 30k. And I mean, you don't have to do this, but it's equivalent to writing it in this particular fashion. Usually we'll write the variable terms first as a convention, followed by the constants, but it's not necessary. And there you have it.